So can someone volunteer to do the derivative for us? The first step? I'll call on people if no one volunteers.
I can.
Cool. Thank you. So why is he doing the derivative of the top piece? Because that's where the 3 is. So he's applying quotient rule. Bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And now the derivative at 3 itself. I would stop cleaning it up. You can just plug in.
Equals plus 1800, which cancel out. Minus over 36, which if my math is correct is negative 50.
You guys agree?
Yep.
So I did it very differently. I have his same first line, but I factored a 600 out right away. So I have t plus 3 minus 3, whatever. So the t and the minus t cancel, and I did it just because I don't like big numbers. So my arithmetic was easier, but same issue. Can I erase the work so we can see the next thing? Yeah? So we showed all the work to get negative 50. The next question, it's not exactly in your textbook kind of curriculum, but it's big time a thing in AP. Using correct units, explain the meaning of that value. Anybody got a go at what that is? Daniel?
Just at hour 3, the tank is draining at 50 liters per hour.
You said the tank is
Draining
draining.
at the rate of 50 liters per hour.
Close. Anyone have something different? Okay, so that it's draining at a rate of positive 50 at time 3, or the water is leaving the tank at negative 15 or 50. Okay, but my got a couple issues. What units are on R in the first place? Liters per hour. And I just did the derivative of that. That's liters per hour squared. So it's, okay. 1/8 Chpt says this, they want the noun, the unit, and the time. Yeah.
When I solved like the derivative, I got positive 50, but like it says that the rate of the draining is modeled by that, so I got positive 50, so it's like draining at positive 50. But I don't know, because when I solved it, I got positive 50, so I just wasn't sure if that was incorrect or if, I don't know.
Um,
But it just like, in the context. it's
Well, because
actually
in the
volume.
context, I agree with the context,
Yeah,
because
yeah,
it
yeah.
says that the rate of the draining is modeled by the equation. So if it was negative, it would actually
Makes
be
sense.
adding water.
I just forgot a negative.
Yeah, because it
Yeah.
should, has to be leaving a part. Yeah, I don't know what it is.
Yeah, so it does come out as a positive, but it is, the rate is the amount, the
Right.
speed that it is leaving.
But like what I'm saying, like if you got negative 50, then it would be saying that it's adding water, because
Right.
it's draining at a negative rate.
Okay, yep.
Wait, can you just explain one more time how it got to liters per hour squared? Like,
Okay.
why does the derivative make it squared?
Well, let's do average rate of change. If we wanted to approximate by doing this up top was liters per hour, and I am dividing by change in hours, right? I hate these, that ask this. I had grade one last year, and it was about pumping gas into a car. And kids said, well, at time over 0 to 5 minutes, this many gallons were added to the tank. And they didn't say gallons of gas. They did not give them the point, which I thought was, yeah. So that you started off with at time 3, they definitely want the time unit. Over 0 to 10 minutes, the tank lost this much water. At time 3, like over time, less gravity, less weight on the stuff, it's going to slow down. Like you needed to say that specific thing. So he said at hour 3 or time 3, the tank is draining at a rate of 50 then units, liters per hour. And technically there's no noun, so they might have needed to see draining this many liters of water per hour every hour. There is a delta math concept there that I will assign at some point because you guys need to practice with them because it's irritating. But, okay. Questions on anything from the practice tests, any of the delta math, any of the related rates questions? What's on the test?
Maxes, mins, extremes.
If I ask you for the absolutes, you need to check the endpoints as well, because perhaps the all-time maximum happened at an endpoint, or maybe the other endpoint wasn't included and there is no absolute minimum. There's a local, there's an absolute, but no absolute min. So, to be able to check. What else?
Points of inflection.
points of inflection happen when concavity changes sign. It's the shortcut, basically. So the second derivative is 0 or undefined. Critical points happen when, Sophia?
When the first derivative changes sign.
Nope.
Is it
Or when it's equal to 0.
When the first derivative is 0, undefined doesn't have to change sign. Yeah.
Wait, what do you call like the inflection thing when you're like solving the second derivative and it's 0, but it's not actually an inflection point? Does that have a
It's
name?
nothing.
It's just nothing?
Yep, first period asked as well. I was like, it is so unimportant, they don't even give it a name.
Okay, so you just don't even need to worry about that. Alright, cool.
Yeah,
Optimization.
everybody's favorite. And then our latest one. Stuff that I only checked on delta math, linearization. Yep,
Wait, so when we're doing linearization, do you want us to do it like with the tangent line? Like, you want us to show the tangent line? Because like in the textbook, when they were explaining it, they like showed it with like differentials and stuff, like, yeah. So, like, are you good if we just show the tangent line?
Yep.
Alright.
so I believe this was on the sample test. Sorry, it's tiny. Okay, so try that one as a linearization. Can you read it? It's kind of warped and stuff, but. So to find the tangent line, I need a coordinate and a slope, okay? What's the function at, where did it request? At x equals 1. Natural log of 1, you need to know is 0. If you don't know it's 0, I will take off points. And in moments of panic, hopefully you can be like, wait, natural log is saying where does e to the something equal 1? E to the 0, okay. Like, hopefully there's a way out of the issue if you had it. Derivative of natural log, 1 over stuff times derivative of stuff, don't forget chain rule. And again, now the derivative at 1, plugging in 1, I think I get 2. And really, to me, the way the textbook, linearization is just the tangent line, but we actually solve for y this time. And they call the y L of x instead of y. Y minus the y value equals slope times x minus the x value. Then it says, use the linearization to find your approximation at 2. Okay. I got 2. Alana, how do I figure out if I have an over or under approximation?
You want to do the second derivative and have it come out.
Okay, so what is the second derivative?
It'll be 2x minus 1 times, if you want to like say all the stuff, or just like the answer.
So, do we need to do quotient rule? Is there a variable in the top and the bottom?
No.
No. So here's the shortcut. I cannot bring myself to write it this way, but if you need to, multiply by the power, lower the power, and then chain rule. So the power was a -1. That second derivative is always negative. The bottom's positive and the top, like the bottom's squared, so the bottom's always positive, and the top is a constant -4. So Constantine, she said we need to look at the sign of the second derivative. It's negative. What does that mean?
It's an over approximation
Because,
because it's this concave down. Like if you like draw a concave down line and then you draw like a tangent line, the tangent line will be above it.
so, took a minute to write down what he said. But what he said was, well, second derivative, and test the second derivative at the place where you made the tangent line. The second derivative at that exact spot was negative, which means the function's concave down. And then he said in words, and I drew the picture, because it's concave down, the little tangent line's gonna sit on top. And the tangent line is linearization, so we plugged in something that's gonna give us a slightly higher value. And even if I plugged in 1.1 or 0.9, whatever, somewhere, something close to 1 on either side, it's gonna be an over approximation. Okay, linearization, as fancy as it gets. It'll come back in chapter 9.
So do we have to write the justification like that?
It's an over approximation because the second derivative is negative at x equals 1. He said lots more words, and I was like, oh, the lots more words are also valid. So for people that don't believe, like, well, why does concave down mean that? Well, because of what he said. Because it's gonna this, and the tangent line's gonna that, and then
Yeah, I get what he said, just if
Yeah.
we're asking for like justification.
Yeah, so justifications have been a little light, and, what's that?
You can't tell
Well, why can't I tell?
because it's not labeled.
Okay, what? Now, can you tell something?
It's a X, or it's a Max, yes.
Max.
Why?
No, there's
Increase
plus times.
to decrease.
So people lost credit, like, it's a max where? At R equals 3. Why? Because DADR changes not sign, but changes from positive to negative. It's not that it changes sign, because if it changes from negative to positive, then it's a minimum. So be careful. Second derivative, why is it an inflection point? Because the second derivative changes sign. That, yes. But at critical points, I need to know, does the slope stop going up and start going down? So it was going up and then started coming down. And why did I know it was an R equals 3? Because I named my derivative. Those of you that, like, it's not wrong, but I will growl at you in red whenever you do A prime, C prime, D prime, because you need to know what is the independent variable. Is it changing with respect to time? Is it changing with respect to the radius? Like this, surface area of the cone, the area of that cross section, how it changes with respect to how the radius changes, or is it something else? Like make your stuff make sense. It really does help you solve things. So justification, the number line's not enough, especially if the number line has no name, because some of you in this class in particular, on the exit card I asked for some justification for why was this a maximum or a minimum. Some of you did the second derivative and said, well, the first derivative had a critical point here, the second derivative was positive, so the critical point is a minimum. Cool, sure. And most of you did a first derivative test, didn't name it, and just went with the number line. That's why. Like, no, I need words. This is stuff from the textbook on all of chapter 4 stuff. Do you have issues with finding concavity or stuff? Ooh. Things. Let's see. If that's the equation of the function, tell me a coordinate where y prime and y double prime are both negative. Paolo, what do you think? P. So first derivative, negative. Is the second derivative negative? Concave up. Stinky poo. You are being recorded. Wasn't me for once. Part B, y prime negative, y double prime positive.
R. No, wait.
Our first derivative is positive. Not feeling good about tomorrow. I was okay for a minute, no.
I swear to God, analyzing graphs is like the hardest thing. I don't know.
Really?
I don't like.
Okay.
Is P not slowing down?
Analyzing graphs.
I don't like it.
Right now, it's really hard with all of the
Okay.
questions.
Guys, the first one, y prime is negative when the slope is going down. When is y double prime positive on the happy face, where is it negative on the frowny face? So, to me, the hardest thing is interpreting the graph and reading it correctly. I am changing its name. Now if it's the first derivative, where where is f double prime greater than 0?
Q to S.
QRSP.
It's halfway
So-
between Q and P.
No, because now it's.
This stuff? So I changed the context. When the slope
Slope is
of,
positive from Q to S.
yeah, so wherever here doesn't have a letter to there. Okay? So it's a matter of what did I give you and how do you interpret it. Where does f have an inflection point?
Wait, F or F prime?
Oh, sorry. Back, I erased it. I meant to keep it as the first derivative. S. And a place that is unnamed. So where is the inflection point when the second derivative changes sign? If this is the first derivative, how can I read the second derivative off of it? It's where does the slope of the first derivative change sign?
So it's like the third derivative of F.
No,
No.
no.
Wait, so like if we were given just, if we were given the original just F X and you asked for the inflection point.
Sorry, say again.
If we were just given like the normal F of X and you asked for the inflection points, it would be different. We can't just look at this slope.
Okay.
Yeah.
Back to the real question, here's the function. The function, how do we read concavity off of that? It's where the happy face turns into a frowny face, which is close to Q, Q-ish. Q-ish, in that region. So where did it stop being concave up and start being concave down would be the inflection point. Versus if it's f prime, it's where the slope of the first derivative changes sign. So wherever here is, and at f.
Does the third derivative measure anything?
It's called jerk.
Does it measure anything?
Well, to me, it's measuring how people learn to drive stick shift. Like, I have a stick shift car and teaching my children on it, good God, whiplash. The third derivative was strong. Don't tell them that.
Did you tell that to them?
No, though students have told them. Some people know them and they're like, your mom said that. Great. They're in college, they shouldn't know. The answers are on there. So let's see. That's an interesting question. Anyone want to try and graph it? So Ben, are they giving us the function, the first derivative, or second derivative?
They're giving us the first derivative.
First derivative, okay.
Maybe that's weird that it says y equals f of x. Oh no, 35 is different. Wait.
Yeah, make it make sense.
Hey, wait, why does it say y equals f of x, but then it says...
Sorry, that's the solution. There we
Okay.
See
You don't just see the answer.
But if the derivative is a straight line, what is the function going to look like?
Curve, parabola.
Parabola. Is it going to be a happy face or a frowny face?
Frowny.
Down. Why? Because the slope of this straight line was negative. Where's the function going to have a critical point, the first one.
At -2, 0, and 1.
So it's going up until here, and then it's going down till some point in time. Does it tell me the function's continuous?
Yes.
Is it still going down from here?
Yeah.
Because the slope is still negative, okay? And Daniel says it's got another critical point at -1, so it needs to go down some more. And I'm not gonna be able to make it clear, but. It should have a wrinkle right there. Like the slope from the left and the right should be different. I'm looking at their answer, it's hard to see their wrinkle too, but there it is. Okay, that's probably too zoomed out. We did this one. I know we did one similar.
I think we did do this one.
They do like the number 5. Then just what's the answer to A?
2 to 5.
Okay. I need more than that. Is it R to H or H to R?
R to H.
So radius to height equals radius to height. But first period also, they said 5 to 2. I'm like, well, who's the 5? Like, connect the other side, which I believe on your paper you would actually do. And first period, we did it backwards again on purpose. We replaced the H with R, and kids were like, but wait, we want the HDT. Oh no, calamity, what are we going to do? Daniel, I don't think we did do this one because the number's ugly. But we did it backwards. So we solved and we got some DRDT and, well, multiply it by 5 and divide by 2 and we have DHDT. Good? And this has another double negative. It says, how fast is the water level dropping? In the end, when we do all the arithmetic, we get negative 0.276 feet per minute. AP will zap you on this if you do it wrong. You could say the rate of change of the water level is that, negative blah feet per minute. But if you say it's dropping at the positive rate, like if you say it's going down, you need to say by a positive number.
It's just always the magnitude.
If you, in your statement, so it depends how people say this. The water level is changing at a negative rate. Okay, it's, by saying it's changing at a negative rate, I'm telling you it's dropping. But if you give the word, it is losing height or dropping height, if you already put the negative in your verb, then it becomes a positive there. Yeah,
Should you say positive rate, or can you just write a positive number?
you can. Yeah, again, things that bothered me while having to grade these. And I would always argue with the table leader, like, oh, come on, they said this, they did these things, and they're like, but they said this one. Seriously, big argument over a comma.
Wait, so like on the AP test, for example, if we get like that last bit wrong, do we get that whole thing wrong, or?
No, so there are, we'll go over what the grading rubrics look like, and like often it's a point to show the relationship of R to H, and then a point to substitute out one of the variables. It didn't matter if you chose the wrong one, but a point for subbing that out, a point for properly doing the derivative with respect to time, and then a point for swapping in the numbers, and then a point for like summarizing your statement at the end. So you would get 5 out of 6 if you said dropping at a negative rate. But still, I didn't think that was worth, 16% of the grade, the dropping at a negative. Well, that means it's getting bigger. I would argue, I do. It's a good thing. Grading has changed places. They've been in Kansas City forever. They're now in Louisville, Kentucky. Ooh la la. I have never gone on site. Can you try that one? The ladder. Sorry, I'll make it bigger. Or I thought I would. So 1 foot per second, is that dx dt, dy dt, the ladder dt?
dx dt.
Okay. And is it positive or negative?
Positive.
Because that distance is getting longer. Okay. Felipe, what other information do I have?
That is you're self-employed when it's 6 feet away from the wall.
Okay, what is 6 feet? Is it X, Y, ladder, X? So they don't tell us what, what's Y? Pythagorean theorem, or 3, 4, 5, just bigger, yeah.
We also there's no change in the ladder, so dl dt is 0.
So what equation am I gonna use to tie them together? Pythagorean theorem. And because L is a constant, I'm gonna just plug in the 10. So 2x dx dt, 2y dy dt equals 0. The 2's cancel out. 6 dx dt was 1 plus 8 dy dt equals 0. So negative 3/4.
Yeah.
What are the units?
Meters per second.
Feet per second.